of the free undamped mechanical system. So I want you to change the damping to 50. I don't like 1250. Can you change that to 50? Okay. No. Wait. I might have done something wrong over here. Wait. Pardon me. No, this one leave as 1250. 1250. And this one, can you change to 50, please? Okay. So we are going to reduce the damping. Okay, we're going to reduce the damping. Okay. So the waveform that you should get, you should see something like this. That is the waveform. Okay. Again, once I finish modifying this Excel spreadsheet, I'll pass to you. Okay. Right. So this is the waveform that we get. Right. My fault. And then long time ago, make sure it is here. No PT. I'm a firm believer. If I can't jump, I don't expect you to jump. Yes.
Is this performance? Really understand stuff?
No, 3 depth, sorry. 1 outer hole. See? Have problem again. Thank you. Okay. I'm a firm believer, if the prof can't do it, don't expect the student to do it. I'm going to teach you how to remember vibration. Are we clear? So my advice to you, don't copy anything. Sit back, look at the log notes, and tell me if I'm right or wrong. Are we clear? Yeah. And there's about a lot of formulas to derive. We read, I'm panicking now. And guess what? It's normal. Are we clear? I'm panicking now. Okay? I don't know. Can I make it? Are we clear? Okay? I'm going to show you it is possible. Okay? If I'm wrong, just tell me you did, you're not wrong. Okay, I'm fine with that. Okay, I'm going to show you. Right. So sit back, refer to your notes when I derive. And more important, what are the key stuff to remember? Okay? What are the key stuff to remember? Remember, mechanical vibration belongs to who? Us. Why? We are cursed with the name, mechanical engineering. There you go. Right. Here we go. So we know in a mechanical system, right? Later on, after deriving, then I'll start doing this question at the same time, okay? So we know that we have a spring mass damper system. So I'll write down here summary. And this should be in your summary sheet, if you are going to do summary for this content. And then you have a damper, and then you have a mass. So this is your mass, this is your K, and this is your C. And we have to deal with this using a characteristic equation. Okay. So a student asked me, what is a characteristic equation? The word characteristic comes from the word what? Character. My character is an impatient. Sometimes I doubt. And I'm very hard on my daughter. So hard that one day he told her mom, Mom, God made me not right. And I feel so bad. Okay. I have to change, okay. So she's 7 and she says that, okay, Daddy. I know. You guys will probably call police, go to his house and get the daughter with the internet. So that is my characteristic. Are we sure? That's my character. Right? So the characteristic of this equation is this. M, there's a mass, d squared x over dt squared plus by c dx by dt plus by kx is equal to 0. When it's equal to 0, we know that this is known as what? Free vibration. Okay. This is the most basic stuff we have to remember. Right? And then if you go to the next step, when you have m d squared x over dt squared plus by c dx over dt plus by kx is equal to f naught sine omega naught t. This is known as a force vibration. In this, we know what are the solutions. Okay, so this is easy. Whatever I don't put in a square box will not be in a formula sheet. Okay, so this will not be in a formula sheet. The thing you have to remember is you have to remember how to draw this diagram. Are we clear? Okay, that will not be in formula sheet. So the next thing we come out, we know that we are going to solve equation 1 using or by finding the roots. Okay. So if we were to rewrite equation 1, we have d squared x over dt squared plus by c over m dx by dt plus by k over mx. This thing is equal to 0. So what we're trying to do now, right? We know from the parent function, I think this is high school stuff. You have ax squared plus by bx plus c is equal to 0. To find the root, right? To find the roots, this is equal to minus b plus or minus b squared minus by 4ac divided by 2a. Now, this is a general formula. I think you all can remember it. Am I right or am I wrong? Okay. So from here, we know that we are going to, I'm going to let lambda 1 and lambda 2 be the roots. So from here, right, lambda 1 and 2 will be equal to minus b. So minus c over 2m, right? Plus or minus square root of c squared minus by 4mk divided by 2m. Okay. So we know we are going to let alpha is equal to minus c, or alpha is equal to c over 2m, and beta is equal to square root of c squared minus 4mk divided by 2m. The next thing that we will remember is this. Okay. We have to know, right? Beta, right, is real
when what? C squared is greater than what? 4mk. Yes or no? So this comes out with our criteria. Okay, so by looking at this formula over here, right, this evolved to become our criteria. All right. So in this context now, we know case number 1. When C squared is greater than 4mk. This is a case where we have an overdamped system. And with this, we know that x as a function of time is equal to C1e minus alpha minus beta plus by C2e multiplied by t, I beg your pardon, minus alpha plus beta multiplied by t. This is a overdamped system. And don't just like, okay, overdamped. Don't do that. Okay. Come up with a sketch to help you remember. Where this is time, and this is x, and this slope reduce slowly, and this is your case number 1. Okay, this should be in your summary sheet. Are we clear? Then the next thing, you know, case number 2. Case number 2 is when C squared is approximately equal to 4mk. This is what we call critical damping. When this is the case, right, beta is approximately equal to 0 because beta is equal to what? C squared minus 4mk divided by what? 2m. So from here, we know that there should not be any beta in the general solution. Yes or no? So we have x as a function of time. This will be equal to C1 plus by C2t bracket E minus alpha t. So this will be provided. Yes.
So what is B1? So the first T, it's the position of the first T, right? C2T, is that term right?
Yes.
B1 plus C2T.
Yes.
Wait, there is no T on the first one, but there is a T on.
Yes. There's a proof for it. Okay, that this is the right expression, but I'm not doing the proof now. Okay, I'm just doing the summary. So from here, we know that the solution looks like this. So this is our case number 2. Okay, case number 2. It's the case where we have critical damping. Okay. Then we come to another situation where we have case number 3. Now, for this case, C squared is less than 4mk, right? So for this case, we have a system known as underdamped system. So when we know there's underdamped system, keep in mind there will be oscillation. Okay. So now the function, the general solution will look like this. Okay, that is now our what? Our general solution. Okay, so we know, given that the function is looking like this, we know that case number 3, or before we go there, okay, so now we reflect on alpha. Alpha is equal to C over 2F, right? And now beta will be equal to what? Beta will be equal to is equal to C squared minus by 4mk divided by 2m. The problem comes with